Okay. Which of the following could be the function of real variable x whose graph is shown below? Explain your choices. So we have a number of options here. Altogether I have 8 different functions. We have to identify which one could be. Not exactly to the dimensions because x-axis and the y-axis are not calibrated. We will only know whether the x-coordinates are positive or negative. Only such information. Other than that, exact values 1, 2, 3, 4, 5 like that, it is not given to us. Okay, so it's a little tricky but not at all difficult. All right, so let us study this graph. Let us look at the graph and we will calibrate it. Like we'll try to find those x coordinate and y coordinate. You know that this is the first quadrant. Here the values of x are positive and the y values are also positive. We all studied about this. In your first quadrant, both x and y values positive, and in the second quadrant, you know that x is negative and the value of y positive. Just for our understanding, writing it down. Third quadrant, both x and y are negative, and in the fourth quadrant here, the x value is positive and y value negative. And anywhere on the x-axis, the value of y will be 0. Similarly, anywhere on the y-axis, x value 0. That's why we say x-intercept and y-intercept. Now, this vertex, let us see. I'm looking at this vertex form of quadratic function. So, this vertex, it happens to be in the which quadrant? It is in the fourth. Let me write down that also. Q1, first quadrant, Q2, second quadrant, Q3, third quadrant, and Q4. Okay, those are the 4 quadrants I was talking about: Q1, Q2, Q3, Q4. Now this vertex is in the 4th quadrant, and in the 4th quadrant you know that the value of x, it's a sign, the x has to be positive and the y has to be a negative one. So it is on the positive x-axis and negative y-axis. So the vertex, the x-coordinate of the vertex is positive and the y-coordinate of the vertex is negative. Now what about the x-intercepts? This is the first x-intercept and it is on the positive x-axis. So it has to be positive, and you know that the y has to be 0. And over here also the x-intercept is positive and y value is 0. This is the only information, and of course the graph is opened upwards. That is, the value of a has to be positive. Okay, this is the info I have. Now look for those. In the first one, you know this is h. In the vertex form you have h, and that is k. And it is f of x is equal to a times x minus h whole square plus k, where your h comma k is the vertex. Okay, now h is how much here? That is 10. It's positive 10, right? X equal to 10, h equal to 10, and k is equal to 5. So both x and y coordinates are positive, you are seeing, for the vertex. But I need a negative one here, right? So do you think this is applicable for the graph of this function? Do you think it goes? No, because it is not satisfying the vertex. So I can scratch off a. A is gone. Now look at this piece. A equal to 2. It is a positive 2. So opened upwards, that is satisfied. Now what is the vertex here? X value 5, that is x or h is 5. I am saying x coordinate. And the y value, that is the value of k, is negative 3. So we are seeing positive for x, negative for y. It is satisfied here. Okay, this function 2 times x minus 5 whole square minus 3 may be the function for this graph, right? It could be the function. So I'm putting a check mark. Now look at the third piece here. X plus 12 whole square. So here x plus 12 means definitely the value of h is opposite of that plus 12, that is negative 12. X coordinate negative and y coordinate positive. Negative 12 comma 10. Is it satisfying this? No, it is just the opposite. Scratch off. This cannot be a function. Now the fourth case, wow, I'm seeing a negative sign here. Negative sign means the graph is downwards. I don't have to go to the vertex. Seeing the negative sign here? No, it cannot be the function. Okay? Okay, now we have functions in the factored form. Like f of x is equal to a times x minus r1 times x minus r2, right? So where r1 and r2 are the x-intercepts. Alright. Now, what is the value of a here? That is 2, positive, opened upwards. That's good. Now what is the x-intercept? X is equal to 3 and x equal to 5. So 3 is positive, 5 also positive. Those two values for x-intercepts. I know that 3 comma 0 and next one is 5 comma 0. It is satisfying. Hence, this could be my function. I'll put a check. Right? Agreed? Now, the next one. Here, the value is plus 5. So, take its opposite. Your R1 is equal to negative 5. The x-intercept is negative 5. Y value 0. And here, it is 7 comma 0. I need both positives, right? First x-intercept, second intercept. They have to be positive. But here this happens to be negative. So this is not my function. Okay, now going to this one. X minus 8 times negative x plus 11. It is something here. Negative x plus 11. How do you handle that? This is a special case. In the second factor, I am seeing that it is negative x plus 11. Alright, let us simplify this in a separate page. Negative x plus 11. I'll do it in detail here. Negative x plus 11. I don't want a negative sign for x. So, how do you handle that? This is one way of doing. There are different methods, but I think this is the easiest one. Negative 1 times x plus 11. This 11 I can write as negative 1 times 11. Negative 11. Agreed? 1 times negative 1 times x is negative x only. And negative 1 times negative 11. Negative 1 times negative 11 gives you positive 11. So we didn't change anything. For your understanding, given I can put them in parentheses. X times negative 1 is negative x. And this negative 1 times negative 11 gives you positive 11. Now, we are seeing that negative 1 is a common factor in those two. So take out negative 1. Leaving behind, in this term, negative 1 is taken out. So you are left behind with x. And then plus negative 1 is gone. So plus negative 1 is gone. So you are left with negative 11. That is negative 1 times x plus and minus gives you minus 11. This is the whole story about this. negative x plus 11 can be written as negative 1 times x minus 11. So directly you can just write off, but background, this is the thing that happens. Let me just give you another example. Suppose if it is negative x plus 8. How do you separate this negative sign from x? Just I'll write negative 1 times x minus 8. That's all. As simple as that. Okay. In case if it is like negative x minus 6. In such case, it is negative 1 times x plus 6, because negative times positive is negative. Okay, now let us go back to our problem here. This one, I can change it to what? Come on. Okay. This is x minus 8. I'm not doing anything to that. But this space becomes times negative 1 times x minus 11. Okay? Negative x, positive 11. And this negative 1, the constant factor, I can even write at the beginning. So negative 1 times x minus 8 times x minus 11. This is just like your factored form, a times x minus r1 times x minus r2, the regular form, factored form of a quadratic function. So here this a is equal to negative, right? A is negative 1. It is a negative number. Even though x equal to positive 8 and x equal to positive 11, those are the x-intercepts, they're satisfying. 8 and 11 are positive. But this a happened to be a negative number. The graph is upside down. So, this function g cannot be your answer. X minus 8 times negative x plus 11 cannot be the function for this graph. Now lastly we have this. It is just turned around. 18 minus x again times 24 minus x. Okay, let us write like the previous one. Let us change it. 18 minus x, you can also write it as negative x plus 18, right? We turned around x, you wrote here, and plus 18. 18 is a positive 18 times negative x plus 24. Using the same concept, I'll change it to now negative 1 times x minus 18, right? Negative times positive is negative x. Negative 1 times negative 18 is positive 18. Good. Times, from this also take out negative 1 times x. This plus I want here, so minus 24. Okay. See how it is turned around. 18 minus x became negative 1 times x minus 18. 24 minus x became negative 1 times x minus 24. This and that just switched with a negative sign outside. Then, what is the product of this negative 1 times negative 1? Negative 1 times negative 1 gives you positive 1. Agreed? So, negative 1 times negative 1 became positive 1 times x minus 18 times x minus 24. A value positive, so definitely the graph is opened upwards. Here x is equal to 18, that is the positive value, and x is equal to 24, that is positive value. So both the x-intercepts are positive and the graph is opened upwards. Both x-intercepts are positive, the graph opened upwards. Therefore, this function may be the function for that graph. So this could be your answer, right? So out of those 8 functions, we got how many checks here? 1, 2 and 3 of them. Okay, and the process you all got it, no? Like this is it. Suppose if the graph is little different, upside down, let me take it little upside down graph, and alright. Now in this case, let me go there. Here what happened? The vertex, you look for a vertex with x value negative, see negative side, x negative, and y value has to be positive. And in the same way, one x-intercept has to be a negative and other x-intercept must be a positive. So likewise, you can just study the graph and figure out whichever function is most appropriate. Okay, thank you.